So, there are two types of quantities. There's vectors and scalars. A vector has a direction and a magnitude. A magnitude is the size of a vector. We can write vectors like these and an absolute value sign. And a scalar only has quantity like meters, kilograms, etc. And the A vector can be in any direction, i.e. like this, but how we subtract vectors is if this is the opposite side of one another, the result would be 0 since there's no length. There's just nothing to they just annihilate. And there is also, you do it like trigonometry, or Pythagorean theorem. Yes, if this is 90 degrees, which it isn't, the result of this vector would be the hypotenuse. Yes. Then there's velocity. First, let's talk about displacement and time. Time, we all know this time in seconds. Then there's displacement. You might have known distance, which is like anyhow where you go, point A to point B. But displacement, let me use this line tool here, be like this, from point A to point B. It's in a straight line. Yeah, like that. Then the formula would be velocity in vectors equals displacement, or S, divided by t. Stop, there's acceleration. It is the change in velocity over the change in time. Or if we just look at velocity, it's actually the change in displacement or change in x coordinate over time. It's the same as just writing v equals s divided by t, and a equals v divided by t. Yes. For instance, if you try to plot a graph, let me take the line tool again, okay. It's perpendicular, by the way. And if we, from the slope formula, delta y divided by delta x equals slope, that means the change in displacement over the change in time. There's no vector there, sorry. The slope, or the m, is equal to velocity. This is not mass, by the way. Then there's, next time we'll talk about Newton's first, second, and third law. Well, if we can